Today, I'm pleased to introduce the session Integrating Multimodal AI in Your Apps with Floom and our guest speaker, Max. Max brings over 2 decades of experience in coding and hacking to his career, marked by substantial expertise in software security and architecture. He is a recognized patent author and has had significant role across the tech industry, including CTO at Amdocs, innovation lead at CyberArk, and CEO at Cars. These roles underscore his depth of knowledge and leadership in technology innovation. Welcome, Max. Today we want to talk about your newest company, Floom. Tell us a little bit about Floom and what the business does. So meanwhile, let me stop sharing since I've heard you got a deck to share.
Yeah. So first of all, thank you for having me, and thank you everyone for joining. And thank you for setting this up, Steffi. So I'm sharing my screen now. Hopefully you can see it.
Yeah.
So basically, Floom is all about helping developers integrate multimodal AI features in their apps. This is what Floom is about. It's an open source solution. So it's being built by the team of Floom and by the community, and by different experts coming from AI and development and architecture and so on. And it's a fairly new project. So we just launched it 3 months ago, but we've been building this for about 7 to 8 months now. That's basically Floom. So this is me, as you mentioned. I have some experience with software development and architecture, which I've been doing for 20 plus years now. I also was chief architect for several companies and started 2 different startups, both of which were acquired. Cards was acquired by Zippo Apps. And the last role that I was doing was CTO of Cyber for Amdocs, which is quite a big multinational company, 30,000 employees. And that's basically about me. Now, with Floom, we're trying to solve, I would say, one of the biggest problems nowadays. You know, a year plus ago, when OpenAI released their ChatGPT, everyone waited for their APIs anxiously, because people understood, you know, it has this huge potential, not only with, you know, simple examples as text generation and code generation and so on, but with identifying patterns in text, in videos, in image, in sound, you know, speech, audio, and so on, and also extracting different details, generating, obviously, and so much more. So we look at AI basically as a very scalable, very, very cheap kind of human being that we can invoke with APIs. This is how we think about AI. And what happened is really, you know, many different approaches came up with developers trying to integrate AI. Most of them are very much focused on code libraries, you know, such as LangChain, Llama Index, Semantic Kernel, and so on. But we kind of immediately felt that there is a big, big gap there, a big problem, or big problems. And we think that the approach that is much more suitable for enterprises has to have some kind of a centralized component that helps manage all the interactions between the applications and the features to the very different multiple AI models wherever they are hosted. So this is why we're thinking about, you know, there's a huge gap. We have AI potential on one side. We have many people who want to integrate AI, but unfortunately, most of them are not really able to do so in a production grade manner, especially with enterprise grade. So this is kind of what we're trying to solve. We felt there's a huge problem, and we sat down for many weeks trying to think about different solutions to these problems. And this is how basically Floom was invented. So basically the underlying causes for this gap, or the actual gap, is, we think, after interviewing many, more than 100 employees from companies ranging from startups to enterprises, then we basically kind of identified, 4 different big issues. The first one is there's no really an enterprise-grade robust development or deployment infrastructure. So we have different code libraries, but they lack centralization management with logging, caching, auditing, monitoring, privacy, security, safety, and so on. And in order to have this fully production-grade pipeline, you'll have to go on a shopping spree on GitHub and try to download many different libraries and so on. And this will create a very, very volatile experience in the perspective of enterprises. So our product is very much focused on enterprise development, and this is basically what we're trying to solve. The second problem, which is, I would say, even a bigger one, is the technical barrier. So nowadays, when we speak to an average enterprise, we hear that Gen AI projects are mainly focused on the data science team or on the innovation team, but they kind of leave out the vast majority of the workforce, which are developers who have zero prior knowledge in AI development. And this is kind of also a thing that we're trying to change. We want to make AI much more accessible. This is, moving this from very specialized and very expensive groups inside specialized companies that are investing in AI into the vast majority of feature integrators, which are developers. The third problem is there's no centralized management right now. So besides all the throughput that goes through the centralized management, as I mentioned before, for caching and for fail-safe mechanisms and so on, and privacy and security, when we integrate AI right now, nowadays, with the existing technologies, we write a lot of code. And this becomes a big code base really, really fast, that is built basically based on 2 different things. The first one is the AI logic itself, either built by a LangChain or whatever. And the second one is all the surrounding infrastructure that developers suddenly realize that they are missing when they try to integrate it in for a very big kind of B2C or B2B product that has very specialized production needs. And this is only for one integration. So it becomes a headache really, really fast. And so just imagine if you would have many different AI integrations, which we definitely think the future, in the future, people will definitely integrate more AI features, then it becomes an unmanageable problem really, really fast. And the last problem, we think, is the inspiration deficit. So right now, when we speak to an average product manager, what we hear is mostly they are focused on code generation or text generation, but they kind of leave out all the other hundreds of different possibilities that Gen AI has to offer. And that's basically what we think the problem is. So the existing AI integration flow right now, kind of the average flow, I would say, is an app, in an average enterprise. Usually has to be Python because, data science love using Python and so on, although most production grade systems are not based on Python for different reasons. So then we have some kind of this connectivity proxy that we need to build to work with code libraries. And then we have some code libraries such as LangChain and Llama Index and many different others, where we build all the logic inside. And then we have all the logic coding. So it's usually data ingestion or RAG mechanisms, embeddings, and so on. So it's being taken care of, obviously, by Milvus, and also by Redis for caching mechanisms and Neo4j for graph solutions and so on. And then we have this fairly new concept that we call AI Gateway, that is providing some infrastructure surrounding this connectivity. So it's usually logging, caching, routing, security, and so on. So you'll have one API and you'll be able to connect to different AI models without changing the API schema or the SDK that you're using. So that's basically kind of how we look at things nowadays and how we think that the average AI integration looks right now. And we thought about this really, really hard. And we came up with this. So this is an entirely new category. And it's called an Floom, which is the AI orchestrator. So an orchestrator basically consists of two different parts. You have the AI gateway inside, which is very similar to different solutions that we have nowadays, such as Portkey and so on. And also, on the other hand, you have the actual orchestrator that helps building the actual logic inside the AI pipeline. We combined two of these, the AI orchestrator and the AI gateway, into one solution, which is open source, by the way. And it's basically logic that handles all the AI logic behind the scenes inside a Docker container that you can place anywhere, because it's Docker. You can place it on private cloud, public cloud, on your developer's PC, which is kind of very close to the developer's IDE. And you place it in between your application and the AI model. It's completely agnostic to any AI model. It's fully multimodal. And we also offer this as a cloud service, so as a SaaS solution, basically. So you have two different options. If you're an enterprise looking, for or under different regulations and you want to use everything internally, great, you can use our Docker container. Or if you're a startup or just want to try Floom out without installing anything, you can use Floom Cloud. So what does it orchestrate, basically? It orchestrates something that we call AI functions. And AI functions are basically, we kind of looked at, two different mechanisms of Gen AI as we know it today. And we have the direct inference, which is the simple one. You have a very simple API. And then you have the agents, which are kind of triggering this thought concept inside an LLM. So what we saw is people are, in the vast majority of cases, are using both as very simple I/O functions, so input, output, different functions. And we decided to distill both of them into one name or one object, which we call AI function. So it resonates with developers because it's a simple function, but now it has AI in it. And these are just some very simple examples of the very large data set that we're building right now with many different hundreds of different AI functions, of things that you can invoke right now in your code within seconds. So just for example, you can extract physical addresses from text and get back a formatted JSON, which will translate into an object that you can actually access in your code, whatever framework you use, by the way. It doesn't have to be Python. And then you have generate speech from text, or the opposite. You can switch between AI models in a matter of seconds. You can try out different models, different configurations, turn on caching, smart caching, use privacy and security mechanisms, and so on. Another example is classify PG rating in videos, or detect objects in images and detect emotions in text, ask questions about data, and so on. So we try to kind of think, in the product manager perspective, why would product managers or how will they benefit from Gen AI in their product, other than the simple text and code generation? So this is how we define an AI function, basically, in Floom. So just forget about the code libraries and forget about the learning curve. It's a very simple, readable YAML format file that any developer with zero prior knowledge in AI will be able to fill out in a matter of minutes. So let me just go through this YAML file. So what you see here is very similar to Kubernetes, by the way. So what you see is we specify the kind of the object that we are defining, which is an AI pipeline. And then we specify the name, then we specify the model. You can specify several models. If one model doesn't work and you want to fall back to another one, then you can easily specify a new model and a set of new rules and make sure that your AI feature will work regardless of the status of the first or default model that you want to use. And it's completely agnostic. So as you see here, this is a URI. And this URI points towards a package or a plugin, as we call it nowadays. And it's basically logic or code logic that you can inject inside Floom. You can build it by yourself. You can download it from our marketplace that we will launch really, really soon. And you can easily debug all the internals and everything else. So you'll be able to easily connect with any AI model within minutes, even if we don't support it by default. So this is kind of the idea of packaging this AI pipeline with many different internal packages that will help you fully customize this procedure from A to Z with whatever logic you want to use. So it's kind of similar in a way to CI/CD and Kubernetes. CI/CD because it's a very distinct flow that you can inject your own plugins into it, and Kubernetes because you now kind of remotely managing your assets. And in this case, the asset is an AI pipeline. So this is what a prompt template looks like. It's really very similar, to different prompt templates. It basically compiles the system prompt and the user prompt. You can use examples that other people uploaded to our marketplace, or you can write your own if you need it. And this is a very important part. So this is what we call context. Context is actually what other people call RUG. But we think RUG is a terrible name, so this is why we use context. And with context, basically, you actually specify the data that you wish to ingest into your AI feature, and basically the knowledge that you want to transfer to your AI model. So it's basically RUG. Now we start with a very simplistic way of showing a very simple and straightforward RUG. Here you can see we are using a plugin that handles PDF files, and we're using one PDF file. I'll show you some more complex examples in the next slide. But for now, let's move on to the next part. And here is how we specify or configure the response. So we want to make sure as developers, not as AI experts, I would say in this case, that the response is being formatted by a plugin that we call Formatter. And this plugin is enabling developers to pre-configure the exact response that they are expecting. One of the biggest problems with AI is the volatility. People are afraid of many times of actually deploying this into production because we don't know what kind of answers we're going to get from the AI back. And this will obviously affect the end users that are using our platforms. So with Floom, what we did is we tried to minimize this risk as much as possible by enabling this formatter that will help you make sure that the answers you're getting back from the AI are exactly what you're looking for. So here we specify text, and we specify the language, and we specify the maximum sentences. And there are many, many different more variables that you can use here. And it is also multimodal. And you can write your own plugin to handle different scenarios. And this is a feature that many people who work with Floom requested. Kind of, I would say the number one requested feature is basically validation. So if we have, an average enterprise, one of the biggest fears is people and consumers will use AI for PII exfiltration. PII is personal identifiable information. exfiltration through the AI, or somehow will use prompt injection to fool the AI to get back credit cards or whatever, or just filtering bad words that we don't want our brand to be exposed with. So our filter here is also a plugin. So anyone can write their own plugin. We're actually working with two different LLM security companies that are already writing their own plugins for Floom. So as a developer, you'll be able to easily set whatever plugin you want to use, validation plugin, and set whatever variables they are expecting, whatever arguments, and then you have this validation plugin working. And this is also a very kind of popular feature. So you have the global here, and global basically means packages or logic that is right for the entire AI pipeline, not only for the response or for the prompt, but for everything basically. And what you see here is we are using a cost management plugin. And this cost management plugin, as I said, very popular kind of with people who are trying out Floom. And you can set the maximum tokens that a user can use a day, or the pipeline can use a day or a month, and so on. So it really kind of eases this very big problem that people are right now trying to solve by themselves. They're trying to write their own AI gateways and trying to manage their own costs by building their own cost mechanisms and so on. And the last one is caching. So, instead of writing your own caching mechanisms, just write, 2 lines of code in this YAML file, and you'll have a fully working caching mechanisms with different arguments. You can use your own, download from Marketplace, and so on. The next thing that you need to do is when you finish editing this YAML file, you need to actually deploy it. So very similar to kind of GitHub or Kubernetes in a way, because you set your YAML file settings and then you deploy it into your Floom instance. So this is the way to do it. It's really, really simple. You install our CLI, and then you just write Floom deploy, specify the endpoint. It could be Floom Cloud, or it could be your own Floom instance, whatever it is. And then you just specify the YAML that you just edited, and that's basically it. You can deploy several YAMLs in one batch, and that's basically how you deploy AI functions. So if we drill down a little bit to RUG, or context as we call it, now with RUG, we are very aware that there are many different use cases. And it should be highly customizable. And this is exactly what we're working on today. We're trying to offer this very customizable and yet easy to maintain and debuggable experience for developers who have zero prior knowledge in AI. And this is basically what we come up with. And what you see here is the last section of context in this specific case is actually ingesting all the files, all the PDF files in this specific path. And it uses different configurations of search patterns. In this specific case, we use L2, which is very popular in Milvus. And here we also specify the top results. And another example is we're using a different plugin, this time for AWS S3. You just edit your own credentials, you set up the path, and then in this specific example, we use cosine similarity, and we specify the top K, which we call top results. And this is basically what RUG looks like in Floom. We are working really hard to make it even more customizable. And everything that is RUG related or embeddings related, which is fully multimodal now in Floom, except the video part, which we will release in no time, in about 2 or 3 weeks, is based on Milvus DB. So that's kind of the way that we work internally in Floom, both in Floom Cloud, by the way, and also in the Floom Docker. We kind of supply Milvus DB alongside in our Docker Compose file. Now, the last thing that a developer needs to do, so we started with the YAML file, we deployed it. Now it's completely managed and orchestrated by Floom. The last thing the developer needs to do is just use our SDK. Now, remember I said before, Python, not everyone are working on Python. Actually, the vast majority of production grade products, high scale and high performant are not based on Python. And we wanted to spare this time of people just building these proxies that help them communicate with their Python code or services. And this is why we released SDK for 7 different most popular languages. So most likely you'll find your language or framework that will have our SDK in it. And that's the only thing you need to do is just write 5 lines of code, specify the AI function that you just uploaded or deployed to Floom, and then just specify the prompt. Now, as I said, it's fully multimodal. So you can send in several prompts, images, byte arrays, whatever you want to send to the AI model. This is a demo, actually, of Floom. It's a recorded demo. So I'll run it. And just before running it, I'll try to walk you through what you're seeing here. So on the right side, you can see the internals of Floom. So you can actually see it on verbose mode turned on. And you can basically see whatever is happening behind the scenes, which is kind of familiar for AI experienced people. It does embeddings and it loads them to the Milvus DB, then runs cosine similarity, I think in this specific case, and gets all the data back into the LLM. And on the left side, what you see is here is the code part. So we have different AI functions here. We have 3 different examples. The first one is Ducks example. So it's a really simple one. We just embed a specific document, a PDF file. It happens to be from an Italian bank. We just scraped the website and run it through embedding. And then we ask it some questions. And then you have the second YAML file, which represents a different AI function, which actually creates images. And the third one is text to speech. So we have 3 different pipelines. And here on your bottom of your screen, you'll see our CLI in action. So let me just run the demo. Okay. So here is the simple, kind of straightforward example, and here's the PDF file that we run through our embedding framework inside Floom. It's just public knowledge straight from a website in Europe. And here we have the actual YAML file that represents what this AI function will look like in Floom. So as you can see, it's extremely simple, very readable. You just specify the model, you specify the prompt, and you specify the response, and that's it. And you have a fully working AI pipeline or AI function alongside, if you want, possibly with caching and security plugins and so on. And on the right side, you can actually see what happens behind the scenes, which is actually we're storing the PDF file, we're parsing it, we're extracting the data. We then use some of the pipeline model connectors to have the embeddings. In this specific case, we're using OpenAI. And then we're pushing the embeddings to the, in the next step, to the Milvus DB. Here, it is already pushed into the Milvus DB. So we created an index, created a collection, and so on, loaded to memory, and inserted all the vectors that are relevant for this specific PDF. And it's, as I said, it's very similar to CI/CD. It's kind of an event workflow, or even a messaging system, I would say, because we definitely believe that in the vast majority of cases, or at least what our experience teaches us, is that AI connectivity or AI integration is almost always very much aligned with a very specific flow. Data ingestion, then building the prompt, building the response, working over different plugins, and so on. So here we can see on pipeline commit, just an example for an event internally in Floom. And this is all done after we've seen the Floom deploy here. And now we have a very simple kind of test code in Python specifically that will run this specific prompt. Who are the team members and the roles of Neva SGR, which is a very big bank in Italy. And then we have this helper tool here. We're entering the choice, the first one, which is the RAG pipeline. Stuff happens here behind the scenes in Floom. And then you have it's actually the full response as we requested from the AI within seconds. Like we didn't need to know anything about AI, anything about embeddings or about RAG and so on, but you have a fully working result that represents the capabilities of GenAI in this specific case. And now we'll go to the image pipeline, or what we actually call nowadays function, not pipeline. But in this case, you can see it's even a more simple YAML file. So just imagine, editing this one YAML file, deploying this to your Floom instance, and that's it. You have a fully working AI feature in your product. So now we deployed it, and Floom ingested this AI function, and now we're testing it. So we're actually trying to run this from Python again. So this is the only code that you need to know about when you run Floom. You actually use the Floom client. You specify the endpoint, your API key with Floom if this is your Floom cloud. If not, you don't even have to have an API key. You specify the function ID and the actual prompt. So the prompt here is a group of investors thinking about investing in AI infrastructure. So we now run, I think, it works with OpenAI, with DALL-E. So we now runs through Floom, and you'll see the answer in a sec. So it's kind of a very bad image that DALL-E produced, but it is working. So it really depends on the quality of the AI model. But the cool thing with Floom is if you don't like the DALL-E quality, you can switch within seconds to any different other AI model without changing even one line of code in your actual product application code. And this is just another example of a different text-to-speech AI function, which you can actually run. We deployed it. Now this is the text that we are sending to this prompt. And we'll have in a sec the actual MP3 file, I think in this case, or WAV file that is actually playing the text from the AI model. So the idea basically here is we try to simplify and kind of generalize the AI accessibility for developers. And as you can see, we have three different very kind of similar looking YAML files that represent AI functions. They are very similar on one hand, but on the other hand, they do completely different things without having to have any prior knowledge with AI. So this is basically what Floom is able to do nowadays. And the reason that we chose Milvus DB was we kind of tried and benchmarked many different vector databases, but we kind of immediately fell in love with Milvus because of the documentation and because of the latency that we got, which was by far much better than the other ones. And it just looked professional, and it felt professional, and it acted professional. So this is why we kind of immediately knew that Milvus is going to be our go-to choice with vector database. The biggest, I would say, benefit of Milvus DB, and especially in enterprise cases, is it's predictable. With enterprise, when you're building software, no matter the scale, you are looking for predictability. You want this software to have very good results, not only in terms of latency and speed, but also in terms of quality, and the lack of crashes or exceptions or errors or whatever. And this is what we found with Milvus. We just tested many different benchmarks on Milvus and all other databases, and we immediately felt that Milvus was the right choice. But how does Milvus exactly enable Floom behind the scenes? So first of all, we rely completely on Milvus for RUG and general embeddings search. So be it cosine similarity, L2, IP, whatever type of search, we always rely on Milvus. We use it multimodal except of video, which we are integrating right now or experimenting with. It is the default vector database for the Floom Docker. So when you install Floom with our Docker compose file, you will immediately get Milvus installed as well. And it is the default vector database for the Floom cloud. So we use Zillis Cloud behind the scenes because it offers scaling and high throughput and good performance. And this is what we're looking for, and especially predictability and reliability. And as I said, we are experimenting right now with multimodal video, embedding cosine similarity search, and so on. So I would say the key lessons that we learned from working with many different, I would say even more than 100 people trying to integrate Gen AI or thinking about Gen AI integration or already have integrated Gen AI in some sense, is that most companies keep Gen AI right now as POCs, which creates this huge gap, as I mentioned before, a gap that we're trying to solve with Floom for many different reasons. But I would say the listed reasons that I gave before are at least what we feel about the specific subject. And another big thing is when I speak to product managers, the average product manager in different companies, what I hear when I ask, how do you think about benefiting from Gen AI, is I usually hear the most classic Gen AI examples, text and code generation, and that's it. And it's kind of a shame because Gen AI is capable of so much more. We already have hundreds of different AI functions ready for use that will definitely benefit many, many different products. But it requires both inspiration and just experience, with Gen AI integration. We've also learned that generalizing Gen AI is hard with our approach, which is obviously not code library where you can basically write anything down, but it's definitely feasible. And it is completely well worth it. And this is one of the biggest lessons that we learned because of the feedbacks that we get. And Gen AI integration is currently reserved to Gen AI enthusiasts and data science group and innovation team. So it kind of, as I said before, leaves out the vast majority of the workforce of the feature integrators, the developers themselves. And the current existing development or deployment methodologies, Gen AI is really not yet production grade in many different cases. So this is basically about Floom. We have 2 slides about our roadmap, which we are very excited to showcase because we are releasing this very, very soon. And it's already being used by different companies, mostly enterprises. So the first thing that we are working on, and I would say it is the hardest thing, it's actually building this generalized AI definition markup language. So it's actually a language that is built off of 3 different stages, 3 different parts. The first one is definition. So we define inference and agents in one object that we call AI functions in simple YAML files. And then we have the configuration, which in most cases, we expect the developers to just use the configuration, just edit it, and that's it. And then we have the orchestration part, which is very similar to CI/CD because it defines this flow of information. going through the logic coding and also through the privacy and security plugins and so on. We package this entire thing into one tar.gz file that will be available on something that we call AI Marketplace. So, and this is the second thing that we will showcase with our roadmap. We're building a community-powered marketplace. And this marketplace is actually this showcasing many different use cases of AI, and not only giving inspiration to different product managers, but also helping developers integrate AI within minutes. So the only thing that you need to do here in this specific marketplace, if you see an AI feature or an AI function that you want to use in your product, for example, convert text to speech, you just click on deploy, and within seconds, you will have a fully working production grade, enterprise grade AI function that you will be able to integrate into your product. And you will be able to debug and customize and so on. The only thing that's left to do is use our CLI to install the specific AI function, as you see here. So this is Floom. I think we have time for QA. And I hope you enjoyed my presentation.
Thanks, Max. It's great. If you have any question, you can just put it at the Q&A button at the bottom of the. Okay, so we see question number one: what AI models do you support right now?
So as I mentioned before, Floom is extremely customizable. So you can actually use the default AI connectors or model connectors that we provide in our marketplace as plugins. And these AI models are actually, right now we support Anthropic, we support OpenAI, we support Ollama and many different others. But you can actually, so it means that we cover the vast majority of the market today. But if you'll have this very new cutting edge or a different API schema AI model that we don't know about, then you can simply write your own plugin within minutes. And when you write your own plugin, you can insert and debug it and use the AI function as you would with any other different AI model. So this is the answer. Okay, I see another question.
Yeah.
Can I run Floom on Ubuntu? So yes, definitely you can run Floom anywhere. This is the idea with working with a Docker container. And we kind of chose Docker containers because of, mostly because enterprises are not willing to exfiltrate their sensitive data to external SaaS companies, especially not startups. And we feel they need this full control inside their own company. This is why we're using a Docker container. So you can run it anywhere on OpenShift, private public cloud, on the developer's PC, which is also something we've heard from developers. They really want to have full and close control of the AI logic. So this is what we're also running on their own laptops. I can see another question. So from Armando, do you support agents and assistants? So we will support agents in about 2 to 3 weeks, hopefully. One of the kind of biggest ideas or notions that we got from when we were building Floom is we distilled both agents and direct inference APIs into one object that we call AI function. Because agents, which, with the perspective of an AI experts are completely different than inference. But from the perspective of a developer, it is basically an IO. So you just send maybe a very complex question or an action to do. It does whatever it needs to do inside the agent itself. And then it goes back with this answer. So in the perspective of developers, AI inference is very much like AI agents. So this is why we will support agents really, really soon. and it will be really fun to build them inside the YAML file because it's so easy. It's so easy to not only build and understand, it's really easy to also debug and just have this high quality kind of great connectivity to AI. So I see another question here. Do you have an SDK for C#? And can I use Floom with REST API? So yes, we have SDKs for C#, for Python, for Node.js, for Java, Rust, and Go right now. Maybe some other that I forgot, but we have them on our website. And because this is a centralized solution, it's not a code library. It's really easy, to create SDKs for it because it's based on a very simple HTTP REST API. So if you don't have the SDK, you can just use the REST API, but just ask us for the SDK and we will probably build it in a matter of days. So that's basically the answer.
We covered every question for now. Any additional questions for Max? Let's give a few more minutes.
Yeah, great. I'll drink some water. So, so yeah, we'll wait for the questions, but it's what I would say with AI. I'm into computers now for about 25 years. Been developing in different frameworks and also cyber stuff and many different architectures, super global scale and so on. When with AI, not that OpenAI invented AI, but OpenAI kind of outed AI to the world, and they conveyed this message. And people immediately understood there's this explosive tool here that we have to harness somehow. And this is what we're trying to do, like with Floom. We really believe that we have to give this power to every developer out there. So this is kind of the idea behind Floom. Yeah, so
Okay.
I see.
Yeah, go ahead, sorry.
Oh, I just wanted to say, I see, there are no more questions right now. And we're just getting started. If you have any feedbacks or any questions, just go to our website or GitHub repository or LinkedIn profile, whatever. Just ask and join our community. I think it's a really kind of a fun process building this.
Awesome. Max, thank you so much for your time. And we look forward to see what amazing thing you're building down the road.
Thank you very much, Steffi, for setting this up, and thank you for everyone for listening. And that's it. We'll see you later.
Thank you. Bye-bye.
Thank you.